Let's go ahead and go back into Visual Studio, and in our UProperty and UFunction macros, let's add more. So put a comma after blueprint read write and type category equals, and in quotes we'll say my variables. Then in the UFunction macro, type a comma and we'll say category my functions. Go ahead and compile this. And once we finish compiling, go back to the editor and right click and type my float. And you'll see now that get my float and set my float are in this new category here called my variables. Go ahead and click the X, and if we go all the way down to variables and click the drop down, we'll see the my variables section, and then we can click that drop down and we see get and set my float. Now go ahead and type my function. And you'll see my function is placed in its own category called my functions. So adding categories to these UProperty and UFunction macros allows us to sort the variables and functions a lot more efficiently by giving them their own categories. There are other macros that you can put in here that can restrict or limit blueprint access to these variables and functions. For example, if we didn't want to be able to write to my float, we could change this keyword to blueprint read only. Once we change that, go ahead and compile, and then go back to the Unreal Engine editor. Now right click and type my float, and you'll see that only get my float is available. Set my float is no longer visible because we no longer can write to this variable, we can only read from it. So this is no longer a valid node, so we can delete that. Go ahead and go back, and let's go to the definition of my function. Now we would like to give some functionality to my function, and one of the most useful tools for developers is logging to some sort of output log. So let's make use of the following command: UE_log, all caps, and type log temp, comma, warning, comma, text, followed by opening and closing parentheses. Now inside of the parentheses, type double quotes, and in the quotes, let's say this is our warning text with an exclamation point. Add the semicolon at the end, and what we just typed is a special macro called UElog. UElog prints text to an output log. Log temp means the category of this type of log is temporary, and warning will ensure that the text comes out on the output log as yellow text, and it will be marked as a warning. So let's compile this, and we'll go back to the Unreal Engine editor. And let's go ahead and highlight these and delete them and compile and save. Go ahead and close this out, and let's double click my actor. We can click on add actor world offset and delete that. And we can right click and drag, and that will allow us to drag up to where we can see event begin play. Now what we would like to do is add a new variable, and the type of the variable we would like to be myObject_BP. Now if we click add new and click variable, down here in components we'll see a new variable, and by default it's called newVar_0. If you go over to the details panel, you'll also see the name of the new variable and the variable type, and the variable type of a new variable in Blueprints can be changed right here. Now if you click on it, you'll see all the basic types such as Boolean, integer, float, string, vector. And then under object types, if we click this, we'll see the basic types such as actor and so on, but we don't see my object. Click search and type my object. We'll see my object here and my object BP. Now my object is the C++ class, and my object BP is the blueprint we created. And we can see that we can choose object reference, class reference, soft object reference, and soft class reference. Now, what we would ordinarily do is click object reference, and we would call this something like my object var for my object variable, and we would drag it into the world, click get my object var, and we'll get a node that says my object var for my object variable. And normally we could drag off of this and access member variables and functions such as my function. So if we click on my function, we'll see that we've got the my function node. And now the my actor begin play can be hooked up to this, and as soon as the game starts, the begin play will call my function from this variable my object var. Now, this is what we would expect, but if we click compile and we go back to our main editor, you'll see that I have this output log right here. Now, you may not have this output log, and if you don't, what you need to do is go up to Window and go to Developer Tools and click Output Log. Once you click that, you'll get the output log down here. Now, this is where a lot of useful information gets printed to the output log. Now, if we click play, you'll see that we get a warning, accessed none, trying to read property my object var. Now, you may be wondering what's going wrong here. So if we go back to my actor and we click on my object var and look in the details panel, you'll see the default value of my object var, and it says none. This is the same thing as like a null pointer in C++. What it means is that my object var is not initialized to anything. There's no default value for it. The default value is none. So we can't actually access a function from it because we're trying to access a function from something that isn't initialized. So because this variable is uninitialized, we need to create a new object of the type myObjectBP. In C++, this would normally be done using the keyword new and the constructor of a particular class. But in Blueprints, there's a special node that does just this. If we right-click, we can type construct object from class. So choose this node, and we'll see that we have an input execution pin and an output execution pin. And we can select from these drop-down menus the class we would like to construct. So here it says the object class you want to construct. If we click that drop-down and type my object, we can choose my object BP. This is the Blueprint version. Remember, my object is the C++ class, my object BP is the Blueprint. If we click on outer, it says owner of the constructed object. Click that and type my actor. This is because my actor is the owner of this object that we're constructing because we're in the my actor class. Now we can drag out my object var and click on set my object var, and into the input execution pin we can connect the line of execution, and then here we have the return value, and this can be connected to the input of set my object var. So now at event begin play, this node will construct the object and its return value will be used to initialize my object var. Now in the set my object var node, we have an output variable that can be used to access my object var and get its functions and variables such as my function. So if we select my function, you'll see that we can call my function from my object var. And of course the target is this blue line here. That's the return value of this node, which will be used as the input for the my function node. So if we zoom out a little bit, we'll see that at event begin play, construct object from class gets called using my object BP, and that will return a my object object, which will then be used to initialize the my object var variable. And then from there we can access my function and call it. So if we click compile and we go back to the editor, we can click play, and you'll see down here we get log temp warning. This is our warning text. Remember, that's what we coded. If we go back to Visual Studio and we go to myObject.cpp, in the myFunction body, we'll see that we have the UElog logtemp warning, and this is our warning text. So we've learned how to create a new C++ class of the type object and create a blueprint from that class. And then, thanks to the uProperty and uFunction macros, we've exposed a variable and exposed a function to blueprints using keywords in the uProperty and uFunction macros respectively. We've also given them their own categories. Then we went into myActor and used construct object from class in order to create an object of type myObjectBP. This is similar to the new keyword in C++. What it returns is an instance of the object we created, and we've used that to initialize our variable here that we created in the blueprint. Then we took that variable we created and accessed myFunction, which we were able to get a hold of in blueprints thanks to the uFunction blueprint callable keyword. So these keywords are what allow us to determine how the reflection system will expose these variables and functions to blueprint.